Okay, so find the asymptotes and how does the function behave around the asymptotes. This one never equals 0 and it's undefined at -1. We'll get a division by 0 at -1. So let's see what this function does in the neighborhood of -1. If x is like -2, sorry, I'll do 1, which is a little bit silly. I'll do x plus 1. And then we have our grand total, which is the first thing over the second thing. You probably don't need to do this much work, but if you like to be by the book, this is how you do it. 1 is positive everywhere. X plus 1 is negative if you're lower than -1. Then it hits 0, and then it goes positive. Positive over negative is negative. Positive over 0 is undefined. Positive over positive is positive. And all that tells us that on our graph, we know we're going to have a vertical asymptote at -1. So the function is scared of that line, and we'll try not to run into it. The function's negative coming up to that line. So it's going to curve this way to try to, like it's trying to avoid running into the asymptote, and it'll just drop forever, basically goes to -infinity. And on this side, because we know the function never reaches 0 out here, it can't reach the x-axis either. It must curve at some point before getting to the x-axis and flatten out. This is called a horizontal asymptote. More about those later. Right at -1, the function doesn't exist for an instant, and on the other side, it's positive. So if it's following the asymptote and positive, it must come down like this. And again, it can never make it to the x-axis because we didn't find any place where it equals 0, so it must pull up. It must pull out of the dive, so to speak, before it gets to the x-axis. So there's our quick and dirty sketch. For this thing, please let that denominator be factorable. F of x is 2 over two numbers that add up to 2 and multiply to -3. I think we can arrange that. X minus 1. Yeah, good. Okay, so this thing is never 0, but it's undefined at -3 and also at +1. So here's our number line. -3 and 1 are the critical values, or the interesting values. La, 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 la. And our pieces are 2, which is positive everywhere. A little bit silly to put it in, but you totally can. X plus 3, which goes -0, plus, plus, plus. And x minus 1, which goes negative, 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 0, positive. So if we combine all that and find the sign of our entire function, 2 over x plus 3x minus 1, how does that turn out? We get positive over negative times negative, positive over 0, undefined, positive over positive times negative, that's negative, positive over positive times 0, undefined, and plus, plus, plus. That one's easy. Okay, can we turn all that into a graph? Probably. First, we know we have asymptote behavior at -3. 1, 2, 3. We have asymptotic behavior at 1. Da, 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 da. And now we just follow our signs. To the left of the first asymptote, we have to be positive. So positive, positive, and now curving to avoid the asymptote means we do that. Just to the right of that asymptote, the function is negative the whole time, apparently. Right? Here's one asymptote. Here's the other asymptote, and between them, the only sign we have is negative, so it must come up negative. It's got to end up negative, and that means it must double back. And we know it never equals 0, so it doesn't even make it to the x-axis. It just turns over like this. And to the right of that asymptote, it's positive the whole time, so that kind of shape. Oh, and because there is no 0, I got to make sure I don't hit the x-axis there. So that's how much information we can get using nothing except the asymptotes.